Hi friends, how are you? Welcome to yet another episode of Subject Science and Technology. In the world of education, of easy education, myself Abhijit, friends, I have been your Maths and Science faculty for 9th and 10th, and the journey of 9th standard has not yet been over. We are in chapter number 4 of semester 2 of 9th standard syllabus. I am talking to all those students of 9th standard watching me right now throughout Gujarat. Friends, don't move for the coming 1 hour because today's episode is going to be the first episode of this chapter. Chapter number 4, chemical bonding, and if you move, you're going to miss something very important. I'm going to start from the base of the chapter. In fact, from the base of the topic, not the chapter, not the standard, not the subject. I'm talking about the topic's base. In fact, if you have missed it out in 7th and 8th standard, if the background of the subject is missing, even you don't worry, I'll recover, I'll take care of that, all things. Stay with me. Let us start today's work. Chapter number 4, chemical bonding. Standard 9th, semester 2. This episode is the first episode of this chapter, chemical bonding. And seriously, I'm going to start from the base. Friends, chemical bonding. I would like to elaborate something about chemical bonding. In this nature, you find many things, many compounds. Let me talk about common salt. The salt which we eat, without which we cannot sustain, without which the food will be the most tasteless. Yeah, that thing, common salt, is known as sodium chloride, NaCl. Okay, it's a compound. You know NaCl, when you speak out sodium chloride, NaCl, Na is one element, Cl is one element. Both of them are combining. Na is one element, Cl is one element, both of them are combined. NaCl. We get a compound. H2O, water. Without water, we cannot sustain our life. That water, H2O, H means hydrogen, O means oxygen. Two elements combining. Talk about numerous elements from H2SO4, sulfuric acid. It's a compound. H means hydrogen, S means sulfur, O means oxygen. Combining. And how is this combination taking place? This combination is taking place by a bond. What is the meaning of bond and bonding? The name of the chapter, chemical bonding. What is bond? You know, bond actually is a word which helps to fix. In practical life, this Fevicol and Fevistick and all sort of gums which you use can be called as bond. Yeah, they can be, in case if you don't want to call it as Fevicol, you can call it as bond. Bond is a substance which binds. Bond is a substance which binds. Now in chemistry, also there is a bond which is invisible. It's not like Fevicol which can be seen. It's not like Fevistick. It's not like Feviquick which can be seen with our eyes. It is there. It is visible under microscope, not the bond. Electron. It all happens because of electrons. You know, atoms of elements, they share the electrons. Atoms of elements share the electrons with more than one atom of other elements. Atoms of one element share the electrons with atoms of more than one element, and this results into chemical bonding. Chemical bonding is again the bond. It's the reason why two or more than two atoms of different elements are combining. It's the reason why two or more than two atoms of the elements are combining and they are resulting into a compound. So that's the basic reason behind the formation of chemical bond, which I'm going to write. What is the reason of the formation of chemical bond? Since the atoms of different elements, exchange the electrons, with the atoms of other elements, Since the atoms of different elements exchange the electrons with atoms of other elements, since this exchange takes place, the chemical bonding is coming into existence. Since the atoms of different elements exchange the electrons with the atoms of other elements, chemical bond comes into the existence. Chemical bond is the basic reason behind the formation of numerous compounds. Chemical bond is the basic reason, the chemical bond is the basic reason behind the formation, the chemical bond is the basic reason behind the formation of numerous chemical compounds. Hence, this was a little elaboration regarding the formation of chemical bond, why it takes place, what is the importance. Friends, and mind well, if the chemical bond is not there in nature, you won't believe, you won't get any compound. Majority of the compounds which we use in our day-to-day life are the result of this chemical bond. So, thanks to chemical bond, later on we are going to study, our topics are including the types of chemical bond, but for now let us have a revision of the topic formation of chemical bond. Since the atoms of different elements exchange the electrons with the atoms of other elements, since the atoms of different element exchange the electrons with the atoms of other elements, chemical bond comes into existence. Okay. The chemical bond is the basic reason behind the formation of numerous chemical compounds. The chemical bond is the basic reason behind the formation of numerous chemical compounds. Okay, now our next topic. Types of chemical bond. Friends, as far as our topic is concerned, our syllabus is concerned, in our syllabus, major stress has been given on two types of basic chemical bond. Chemical bonds are of two types: ionic bond and covalent bond. In the initial part of the chapter, we are going to put stress on ionic bond. But just for information, remember that if the question is what are the types of chemical bonds, the types of chemical bonds basically are of two, namely ionic bond and covalent bond. Chemical bonds are of two types. Ionic bond and covalent bond. Now, both of them are dependent on octet rule. Both of them are dependent on octet rule. Both of them are dependent on octet rule. Now discussing ionic bond. Friends, ionic bond will be our first category of bonds. Ionic bond. It's damn important. For our support, we are going to take the example of NaCl. NaCl is our target. It's the main idea behind explanation of ionic bond. Unless we take the example of ionic bond, you won't have a clear concept, you won't have a clear picture of what actually ionic bond is. Anyhow, the initial part of the topic was types of chemical bond. Chemical bonds are of two types, ionic bond and covalent bond. Both these types of bonds are dependent on octet rule. Both these types of bonds are dependent on octet rule. Anyway friends, ionic bond, NaCl. sodium chloride. We call it as common salt. Common salt is what we eat daily. Without common salt, friends, you won't believe, you won't get iodine. It's the basic source of iodine to our body. It helps the pituitary gland in all-round growth, in all-round development. The mental and physical development are the result of sodium chloride, iodine. Anyway, it's not a physical environment or health education class. It's class of chemistry, and we are into some very solid, tough topics of chemistry. Now let us come back to the topic of ionic bond. Ions. What is the meaning of ion? I-O-N. Atoms are gradually converted into ions either by losing electrons or by gaining electrons. So mind well, when an ion is formed and with the help of ions, bonding takes place. Right now you don't have any imagination capacity. Let me elaborate it. Ions, what are ions? Whenever an atom loses or gains electron, it forms ion. Maybe positive, maybe negative. I'll come to it. When is positive ion formed? When an atom loses electron, it forms positive ion. Depending upon the number of electrons lost. For example, if an atom loses 1 electron, it will have plus 1. Okay. If it is losing 2 electrons, its ionic number will be, the power will be plus 2. It forms positive ion after losing electron. Exactly opposite. If it gains electron, it will form negative ion. Okay. Depending upon the number of electrons gained, it will be decided the extent of its negativity. So there are two types of ions, positive ion and negative ion. When is positive ion formed? When an atom loses electron, it forms positive ion. If an atom gains electron, it will form negative ion. Thus, the topic comprises of ionic bond strictly depending on ions. And what are ions? I have explained. Now come back to the topic of NaCl, sodium chloride. We will discuss Na first and later on Cl. Let us come to the topic of Na. Sodium, Na, its Z is equals to 11, which means atomic number is equals to 11. You know, sodium, if you take out the periodic table, you will find sodium having atomic number 11. Z is equals to 11. So its configuration is 2, 8, 1. Its configuration is 2, 8 and 1. Now, since the configuration is 2, 8, 1, you can check out, it will try to come to the nearest stable inert gas. It will try to become 2, 8. In that case, in that procedure, in that process, it will lose 1 electron. Sodium, Na, atom, this is the atomic number of sodium, 11. So its electronic configuration will be 2, 8, 1. I repeat, since its atomic number is 11, the distribution of electron in the first orbit will be 2, it is completely filled, 8, completely filled, and in the third orbit, it will have 1 electron. Now this 1 electron will be the hindrance in becoming stable. So what sodium atom will do, it will try to get escape of that 1 electron by losing it. It loses that 1 electron and forms Na plus Na positive ion because it is losing. Hence, Na loses 1 electron to become stable. Na loses 1 electron to become stable. Therefore, the reaction will be, this is sodium 281 atom, loses 1 electron, it loses 1 electron, becomes Na positive and 1 electron will be released like this. Na plus ion, which is 2,8, and 1 electron is released. 1 electron is released. I repeat the whole procedure. It's a gradual process which you need to understand. We are segregating the topic of sodium chloride into two parts. Sodium will be discussed first, then will be chlorine, and at last we will merge both of them into one single compound. Ionic bond, sodium chloride, I am talking about the common salt. It's an ionic compound. Why? Because those compounds made with ionic bond are known as ionic compound. In that case, we are going to discuss sodium first. So, sodium, Na, Z is equals to 11. Its atomic number is 11. So, its electronic configuration will be 281. In the first orbit 2, second orbit 8, and third orbit 1. Now, hence, Na loses 1 electron. Sodium, in order to become stable, because it's always, every atom tends to become stable, tries to become stable. So will sodium. Sodium loses 1 electron. So 281, since the outermost orbit has only 1 electron, it is a hindrance. It is a big hindrance. Yes, friends, it is a big hindrance in becoming stable. See the stable octet, helium, neon, argon, krypton, these all are having stable octet configuration. Helium 2, neon 2, 8. Okay, so 2, 8, 18 and so on. These all are stable. So even sodium will try to become stable. Yes, it tries. It loses 1 electron, and this is the description. Sodium 281, it's an atom. It's not stable. When it loses 1 electron, which is shown over here, electron minus. The rule of losing and gaining is very much fixed. If you lose electron, you will be converted into positive ion. So will be sodium. Sodium loses 1 electron, becomes Na positive, 2,8. Now it is stable, isn't it? Yeah, it is stable. But it is ion, Na positive, and electron is released. So this was the detail of sodium. Now we are going to study chlorine. What about chlorine? What is the electronic configuration of chlorine? What is the atomic number of chlorine? It's 17. We need to mention for chlorine. For chlorine, Z is equals to 17. Therefore, electronic configuration two, 8, 7. The electronic configuration is 2, 8, 7. Now, depending on again the same rule, chlorine will try to become stable. Now, chlorine has two options. Come on, we will discuss the option. Chlorine atom configuration 287, it thinks of becoming stable. It can become stable by losing 7 electrons. If it loses 7 electrons, it will become 2,8. Otherwise, it has one more easier option. If it gains 1 electron, it will become 288. Which one will be easier? Tell me. Losing 7 electrons is easier or gaining 1 electron is easier? Which one is easier? Always in comparison of losing 7, gaining 1 is more easier. So chlorine will opt for that option, 288. It will try to become 288 by gaining 1 electron. So let us perform it. Let us write the step. Hence, in order to become stable, chlorine atom gains 1 electron, and becomes negative ion. Like this, Cl 287, its atom, it gains 1 electron, E negative will be added and it will become Cl negative 288 ion. Now you need to keep two pictures in your mind. The first picture was of sodium, which has lost, which has donated, which has given 1 electron. If you donate, if you lose electron, you will become positive. So we had Na positive ion, right? Na positive, and we have Cl negative. So negative ion and positive ion will be attracted. I repeat, negative ion is chlorine, positive ion is sodium, Na positive. So in nature, Na positive ion and the Cl negative ion will develop a strong attractive force, a strong attraction will develop a strong attraction in nature. Na positive and Cl negative ion will develop a strong attraction towards each other. They will develop a strong attraction towards each other, and we get a compound NaCl. And as a result, they neutralize each other and compound NaCl is formed, like Na positive plus Cl negative gives NaCl. Okay, so this was the explanation. Let us have a quick revision, a detailed one. For chlorine, Z is equals to 17. This is when we have already discussed Na. Sodium is already done and dusted. Its atomic number is 11, so it was 281. It has lost one electron, have formed Na positive. Now for chlorine, Z is equals to 17, so electronic configuration is 287. So in order to become stable, chlorine atom gains one electron to become negative ion. Chlorine atom gains one electron, becomes negative ion. So Cl plus electron gives Cl negative. Why? Because the rule of nature is fixed. If you give electron, you are going to form positive ion. If you gain electron, if you are gaining it, it will be negative ion. So chlorine gains one electron in order to satisfy its need of becoming stable. It becomes Cl negative, 288 ion. In nature, Na positive, which was formed previously in the last board work, and Cl negative ion will develop a strong attraction towards each other. Na positive, Cl negative attracted, and we get a compound NaCl. And as a result, they neutralize each other and compound NaCl is formed like this. Na positive, Cl negative